Lesson 21.1, using probability to make fair decisions. How can you use probability to help you make fair decisions? Let's see, probability offers a method for representing a population in an unbiased way so that decisions can be made fairly. All right, using probabilities when drawing at random. You are sharing a veggie supreme pizza with friends. There's one slice left, and you and a friend both want it. Both of you have already had two slices. What is a fair way to solve this problem? Suppose you both decide to have the same amount of pizza. This means that the last slice will be cut into two pieces. Describe a fair way to split this last piece. Let's see, how about one person cuts a slice. One person slice into two approximately equal pieces. Then the other person gets to choose which piece they want. That seems pretty fair. Let's see here. Suppose instead you decide that one of you will get the whole slice. Complete the table so that the result of each option gives a fair chance for each of you to get the last slice. Why do each of these possibilities give a fair chance? Flip a coin. Heads, result, heads, you get the slice. Tails, they get the slice. Roll a standard die. If he gets 1, 3, and 5, you get 2, 4, and 6. Play rock, paper, scissors. You win or you lose. Drawing lots using two straws of different lengths. Long straw, you get the last slice. Short straw, you don't. Each of those got like a 50-50 chance of you winning or losing. So let's see here. 4 for each option. Both results have a probability of 1/2. So both people have the same chance of getting the last slice. Suppose when down to the last piece, you tell your friend, I will cut the last piece and I will choose which piece you get. Why is that method unfair? Well, I could slice it. I could slice a piece into 2 pieces with one much larger than the other. And then choose the larger piece for myself. But I wouldn't do anything like that. All right. So your friend suggests that you shoot free throws to decide who gets the last piece. Use probability to explain why this might not be a fair way to decide. Okay, I don't think shooting free throws, shooting free throws is not a random event. The person or the player with more skill, let's see, the player with more skill will have a greater probability of winning. All right. Awarding a prize to a random winner. Suppose you have decided how to award a prize to a person at an event. You might want every person attending to have the same chance of winning. Or you might want people to do something to improve their chance of winning. How can you award the prize fairly? The sponsor of an event wants to award a door prize to one attendee. Each person in attendance is given a ticket with a unique number on it. All of the numbers are placed in a bowl and one is drawn at random. The person with the matching number wins the prize. The method of awarding a door prize is fair. Each number has the same chance of being chosen, so each attendee has an equal probability of winning the prize. If n attendees are at the event, then the probability of winning the prize is 1 over n for each attendee. A fundraiser includes a raffle in which half of the money collected goes to a charity and the other half goes to one winner. Tickets are sold for $5 each. Copies of all the tickets are placed in a box and one ticket is drawn at random. The person with the matching ticket wins the raffle. The method of choosing a raffle winner is, I would say it's fair, because each ticket has an equal probability of being drawn. In example 1B, the probability may not be the same for each person to win the raffle. Explain why this method is still fair. Well, for each ticket, the probability of drawing the matching ticket is the same. So for each ticket, the probability of drawing the matching ticket is the same. A person who buys more tickets should have a better chance of winning. All right. Each month, a company wants to award a special parking space to an employee at random. Describe a fair way to do this, include a way that ensures that a person doesn't win a second time before each employee has won once. Well, let's see. You can choose an employee's name at random. From a list of all employees. Each month, remove the previous winners. Remove the previous winners' names from the list. Once every employee has won, begin again. With the list of all employees. Pretty cool. All right. Solving real-world problems fairly. Use a random number generator to choose a winner of a prize. Use a problem-solving plan. A class of 24 students sold 65 magazine subscriptions to raise money for a trip. The table shows 3 of the students and the number of subscriptions each sold. As an incentive to participate, you will award a prize to one student in the class. Describe a method of awarding the prize fairly. Use probabilities to explain why your method is fair for the students listed. All right. Let's see. It says there are 24 students, and they sold 65 magazine subscriptions. There's one prize, so who will be the winner? To be fair, Students who sold more subscriptions should be given a better chance of winning the prize than students who sold fewer. Find a method of assigning outcomes so that the chance of winning is proportional to the number of subscriptions sold. The class sold 65 subscriptions. So assign numbers 1 through 65 to the students. Each student gets as many numbers as the number of subscriptions he or she sold. Well, Miri sold 5 subscriptions, right? So let's see, 5 over 65 is about a 7.7% chance. Liam sold 2. So 2 over 65, that's about a 3.1%. And Madison didn't sell any, so she has a 0% chance. Then use a calculator to find a random digit from 1 to 65, 1 through 65. Then, for instance, if the result is 7, Liam wins the prize. All right, let's check out our calculator. And let's go to calculate, and then menu. And 5 for probability, 4 for random number. And then we'll put in 1, 65. Too many arguments. 1. Uh-oh. That's the wrong one. Menu, 5, 4, 2, 1, 65. There you go. And if you go up there and grab it again, you get a different number each time. All right, so that's how that works. Random integer. Justify and evaluate. This method seems fair because it gives everyone who sold subscriptions a chance of winning. You could award a prize to the student who sold the most subscription, but this might not be possible if multiple students all sold the same number, and it might not seem fair if some students have better access to buyers than others. 5, reflect. A student suggests that it would be better to assign the numbers to students randomly than in numerical order. Would doing this affect the probability of winning? Well, since you're using a random number generator, no. Each number has the same probability of being chosen. So it does not matter which numbers are assigned to each student. All right, cool. A charity is giving a movie ticket for every 10 coats donated. Jacob collects 8 coats. Ben collected 6, and Ryan and Zach each collected 3. They decide to donate the coats together so that they will get 2 movie tickets. Describe how to use a random number generator to decide which 2 boys get a ticket. Well, the boys calculated a total of 20 coats. Assign Jacob numbers 1 to 8, Ben 9 to 4, Ryan 15 to 17, and Zach 18 to 20. All right, so, first off, there's several ways to do this. So let's see here. Ben collected 6. So Ben, we'll get 1, 2, 3, 4, 5, and 6. Whoa, I'll say Jacob did 8, so we'll put Jacob here. Jacob, 7, 8, and then Ben, 9, 10, 11, 12, 13, and 14. Ryan, 15, 16, 17, and Zach, 18, 19, and 20. And then we go to our random number generator. And let's see here. I'm going to just go up there. Well, I better not do that. Menu, 5, 4, 2, and then 1, comma, 20. So 11 was the first one. Let's see, 11. So Ben gets to go. And let's go up there and grab another. And 9. And, oh, that's Ben again. So let's do it a third time. 15. So Ryan gets to go. All right, so Ben and Ryan get to go. So that's a way to do it. Solving the problem of points. The decision-making process that you will apply in this example is based on the problem of points that was studied by French mathematician Blaise Pascal and Pierre de Fermat in the 17th century. Their work on the problem launched the branch of mathematics now known as probability. Two students, Lee and Rory, find a box containing 100 baseball cards. To determine who should get the cards, they decide to play a game with the rules shown. One of the students repeatedly tosses a coin. When the coin lands heads up, Lee gets a point. When the coin lands tails up, Rory gets a point. The first student to reach 20 points wins the game and gets the baseball cards. All right. As Lee and Rory are playing the game, they are interrupted and unable to continue. How should 100 baseball cards be divided between the students given that the game was interrupted at the described moment? So I'll let you read A. We kind of need to, let's see. At most, 3 coin tosses have been needed for someone to win the game. At most, 3 coin tosses would have been needed for someone to win the game. Make a list of all possible results using heads, H for heads and T for tails, drawing boxes around the outcomes in which Lee wins the game. All right, and they did that for you. There are 8 possible results. 1, 2, 3, 4, 5, 6, 7, 8. Lee wins in 7 of them, and Rory wins in 1 of them. The probability of Lee winning is 7/8, so he should get 7/8 of the cards, which is 87.5 cards. The probability of Rory winning is 1 in 8, so he should get 1/8 of the cards, which is 12.5 cards. Rather than split a card in 2, they might decide to flip a coin for that card or let Lee have it because he was more likely to win. When they are interrupted, Lee has 18 points and Rory has 17. At most, 4 more coin tosses would have been needed. Okay. List all possible results. Draw boxes around the outcomes in which Lee wins. So 4, that would have been H, 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 H. This would have been tails, heads, 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 tails, heads, 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 tails, heads, 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 tails. Okay? This could have been tails, tails, heads, heads, tails, heads, tails, heads, tails, heads, heads, tails. Let's see. And then heads, tails, tails. And then heads, tails, tails. All right, 3 tails and 1 head. That would have been tail, 2, 3. Heads, tails, tails, heads, tails, tails, heads, tails, tails, tails. Oh, excuse me. I should have been heads, tails, tails, tails. And then 4 tails would have been 1, 2, 3, and 4. Now, draw boxes around the outcomes in which Lee wins. That would have been this one here. That would have been all of these. All of these. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. I don't think that's quite right. Let's see. 4, 8. Head, tails, heads, 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 tails, heads, 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 tails, heads, 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 tails. We got tails, tails, heads, heads, tails, heads, tails, heads. And then we got tails, heads, heads, tails. And heads, tails, heads, tails. You know what I'm missing? I'm missing heads, tails, tails, heads. Okay? So there we go. So there are 16. Now, how did I know 16? What is 2 to the 4th? 2 to the 4th is 16. That's how I do. Lee wins in, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them. And Rory wins in 1, 2, 3, 4, 5. 5 of them. Okay. The probability of Lee winning is 11 over 16. So he should get 69 cards. The probability of Rory winning is 5 over 16. So he should get 31 cards. A student suggests that a better way to divide the cards in example 3B would be to split the cards based on the number of points earned so far. Which method do you think is better? This suggestion would result in dividing the cards about evenly, 51 for Lee and 49 for Rory. The solution in the example comes close to the intended result that one student wins all of the cards. This suggestion would result in dividing the cards about evenly. Uh, 51 for Lee, 49 for Rory. Which method do you think is better? Well, I think the original thing with the game was that one would get all of them or something like that. So the solution in the example comes closer to the intended result that one student wins all the cards. Because remember, the first 1 to 20 got them all. Describe a situation where the game is interrupted, resulting in the cards needing to be divided evenly between the two players. Well, if the game is interrupted when the players are tied, they each have a probability of winning equal to 1/2. If the game is interrupted when the players are tied, they each have a probability of winning equal to 1/2. All right, good. Elaborate. In the situation described in the Explorer, suppose you like the crust and your friend does not. Is there a fair way to cut the slice of pizza that might not result in two pieces with the same area? Well, if you like the crust, let's see, and your friend does not, you could cut, if you cut the slice so that one person or one piece has all of the crust, but little topping. Then the crust piece might be larger, but your friend might consider it fair to receive the smaller piece. Since it has the most toppings. Cool. How would the solution to example 2 need to change if there were 2 prizes to award? Assume that you do not want one student to win both prizes. How would the solution to example? You could award the first prize the same way. Once the first prize is awarded, either all of the numbers are assigned to that winner would be ignored when randomly generating a second number, or the winner's numbers have to be reassigned to people with the highest numbers. For example, if Leon won the first prize, then his numbers would be reassigned to the person who has the 2 highest numbers, 64 and 65. Then use random integer 1 to 63 to award the second prize. Remember how we did this over here? Let's see here. How we did, kind of like that. Once, Ben won, and then we ignored those numbers a couple of times, I think. We ignored 9. We ignored 11 and 9. And then you could do it that way there, or you could since Ben won, then you would do Jacob is 1, 2, 3, 4, 5, 6, 7, 8. And then Ryan would be 9, 10, and 11. And then Zach would be 12, 13, and 14. And then you could go back and say random generator, and then let's change this to 14. Change that to 14. Make sure we got that right. Yeah, 14. And then press enter. And then, okay, and now Ben won. Okay, or Jacob won. So you can do it either way. Either way would work just as well. Essential question. Describe a way to use probability to make a fair choice of a raffle winner. If people are buying raffle tickets, then each of the N tickets should have the same chance of winning, 1 over N. You can select a ticket randomly from a box or use a random number generator to select the winning number. If people are buying raffle tickets, if people are buying raffle tickets, then each of the N tickets, then each of the N tickets should have the same chance of winning and that would be 1 over N. Okay, you can select a ticket randomly from a box. You can select a ticket randomly from a box, or use a random number generator. But you better check out who you have for your, need to be careful who your audience is, because you pull out a calculator and do that with a random number generator. I think the crowd is going to get a little mad because they're going to think there's a little voodoo or something like that involved in it. Okay, so you might ought to just draw it out of the box. Folks, great lesson. Thank you very much. You have a nice evening. I'll see you in class tomorrow.